before you start doing the problem. Alright, 10% of customers at a gas station quick shop buy milk. What is the probability that of 5 sequential customers, but A, all 5 buy milk, B, only the first of the 5 buys milk, and C, only one of the 5 buys milk? Okay. Again, if you're ready to do this type of problem, pause the video and restart it when you're ready. Alright, so this problem, as I said, could either be with or without replacement. Okay. If you tried it yourself and tried it, how should I say that, without replacement, okay, think of the following. If you have a problem without replacement, like candy in a jar, you need to be told that, for instance, 50 people came in that day, 5 of those 15 bought milk. Okay? And then you could answer those probabilities. That's when it's sampling without replacement. Because with replacement, okay, even though we have 10% of the customers buying milk, 5 of them, we could have all 5 buy milk. Alright? So that's the type of example this is. This is with replacement, since we don't know the number of customers that came in that day, and we don't know that, say, 5 out of the 50 bought milk. We'll just say that 10%. So this is a global average. On any one day with 50 customers, they might have all of them buying milk. It's unlikely, but it could be. Okay, so this is sampling with replacement. It's like a coin toss. So, A, all 5 buy milk. So, milk, milk, milk. It's 1, 2, 3, 4, 5. Right? So, that's first one is 10%, second one is 10%, third one is 10%, fourth one is 10%, fifth one is 10%. Or if you like, 0.1 to the fifth power. Alright, and the answer to that is 0.00001. Okay? You're multiplying 0.1 or a tenth to 5 times. Alright, part B. Only the first buys milk, so there's a probability of milk, no milk, so I'll just write no N. Alright, no milk, no milk, no milk. So the first one buys milk. That's, we're told the order, so first one 10% buys milk, and then we have 4 customers that do not buy milk, so 0.9 or 90% 4 times. Okay, and the answer to that, once you've pulled out your calculator and worked it out, is 0.06561. Alright, and then part B. Sorry, part C. Only 1 out of 5 buys milk. Right? So 1 milk in 5. Right? So this is one of those problems where you're not told the sequence, like in part B. So there's a number of ways times the probability of one way. How many ways are there of getting 1 milk in 5? Well, either the first could have milk, the second, or the third, or the fourth, or the fifth. There are 5 ways. Okay, so it's a probability of one way. Well, the part B tells you the probability of one of those ways, right? The first one gets milk, and that's 5 times 0.06561. Alright, and the answer to that is 3281. Alright, so that's that problem. Both with replacement, without replacement, several sets of examples. In the long run, hopefully you've understood that in this case we had 5, which is more than the 3 that we did in the typical problems. But if we had, 100 defects, 100 items, and we wanted to find the probability of one defect, and in 100, we want to know the number of ways of getting one defect in 100. Of course, you can't list them all out, but either the first one could be a defect, or the second, or the third, or the fourth, or the 100th. Clearly, there's 100 ways of getting one defect out of 100. Similarly, if you go to 1,000 items, then you will probably find the probability of one defect, but the number of ways of getting one defect out of 1,000, again, is either the first or the second or the third through the thousands. There are 1,000 ways of getting one defect out of 1,000, right? Okay. Alright, we'll end this video here. It's not the end of probability theory. We'll have another segment, but that segment is more difficult. But hopefully you've paused this video and taken breaks throughout this period.